Now we are going to discuss about in the last class we have discussed shortest of first algorithm. The shortest of first algorithm contains two versions. One is a preemptive version and another one is a non-preemptive version. In the non-preemptive, so yesterday we have discussed about this non-preemptive version. That means once a CPU given to the process, it cannot be preempted until it completes its CPU burst time. So whatever the CPU burst time is assigned to that particular process, a time complete అయిన తర్వాతనే that process comes from the CPU. Means once a CPU given to the process, it cannot be preempted. Means it cannot be preempted means partial execution అనేది ఉండదు until it completes its CPU burst time. That means if the process requires 10 microseconds to complete that particular task, so if 10 milliseconds are completed only, then the CPU come out from the process come out from the CPU. So that is what the non-preemptive version. Yesterday we have discussed about this non-preemptive version. And in the shortest of first, one more version is also there, that is the preemptive version. If a new process arises with the CPU burst time length less than, that means one process is executed inside the CPU, another process is stored into the came into the ready queue with minimum burst time compared to the remaining burst time of the process which is currently executed in the CPU. That means whatever the process currently executed in the CPU, that while executing that one, so the remaining time is suppose for example if the process requires a 10 milliseconds burst time. So now the 10 milliseconds burst time process is like this. Suppose here suppose observe here, suppose you can observe here, suppose P1 is some process, here P1 is some process and P2 is some other process and P3 is some other process. These are the three processes are in ready queue. Okay, these three processes are in ready queue. Okay,
కనిపించడం లేదు.
వైట్ బోర్డ్ కనిపిస్తుందమ్మా. ఇంతకుముందు క్లాస్లో వైట్ బోర్డ్ కనిపించింది కదా మీకు.
ఓకే,
వెయిట్ చేయండి, అది మీకు స్లో ఉందేమో. లావణ్య లావణ్య కనిపిస్తుందా అమ్మ నీకు వైట్ బోర్డ్?
సంథింగ్ వెంట్ రాంగ్ అని పడుతుంది మ్యామ్.
ఏంటండి సంథింగ్ వెంట్ రాంగ్ అంటుందా? ఇంతకుముందు క్లాస్లో వైట్ బోర్డ్ కనిపించిందా మీకు?
కూడా నాకు అలాగే పడింది.
ప్రాబ్లం రీతు నీకు కనిపించిందా?
లేదు,
కనిపిస్తుందమ్మా వైట్ బోర్డు. స్క్రీన్ షేర్ అయితే వైట్ బోర్డ్ కనిపించదు. Suppose observe here, now it is visible.
Yes, ma'am. Yes, ma'am.
Okay, P1, P2, P3 are the processes. Now, suppose these processes have the bus timings are, suppose this process bus timing, suppose some 10 milliseconds, and its process bus time is suppose some 15 milliseconds, and this process bus time is suppose some 16 milliseconds. So, on these three processes, which process have the minimum bus time? P1 is has a minimum bus time. So, while executing this P1 process in the CPU, suppose some other process after completion of 5 milliseconds, that means whenever this P1 process enter into this CPU after completion of 5 milliseconds, now one process, that is a P4 process, can assume like that, this P4 process with the burst time is 5 milliseconds. So suppose this P1 process with the burst time, 4 milliseconds. That means here P4 process is enter into this ready queue. Here this P4 process is enter into this ready queue with the minimum bus time is, what is the bus time is here? 4 milliseconds. So that means for executing this P4 it requires only 4 milliseconds. So here currently executed process is what? P1 is a currently executed process. So after completion of 5 milliseconds, remaining 5 milliseconds are there. So at that particular time, one more process enter into this ready queue with 4 milliseconds bus time. So comparatively this 4 milliseconds and with this 5 milliseconds, these 4 milliseconds are very, that is 4 milliseconds. Here 4 milliseconds are less than 5 milliseconds. Okay, this 4 milliseconds are less than this 5 milliseconds. So that this process is preempted from the CPU. That means P1 is preempted from the CPU and P4 process enter into this CPU. Now the execution is start. So this type of version, this is also called as the shortest job first algorithm with preemptive version. Why? Because here this is a preemptive version, means whenever, suppose see here the definition for this, here if a new process arrives with CPU burst length less than remaining time of current executing process, that means currently executing process remaining time kante, now whatever the process is newly entered into the CPU, that process burst time is less than, then this currently executed process is preempted and newly entered process or newly arrival process enter into the CPU. That means if a new process arrives with CPU burst time less than remaining time, that means here this is a P4 is a newly arrival process with less than currently executed remaining burst time, that is remaining burst time is 5 milliseconds. Here the process, new process arrives with the CPU burst time 4 milliseconds. This is a less than. Now this is preempted. This is come from the that means comes out from the CPU or preempted from the CPU. That means preempted means complete kaakamunde execution time 10 milliseconds complete kaakamunde it comes out. That is nothing but preempted. Munde empty avutundi. So ekkada nundi? CPU nundi. So that's why the name is preempted. Now P4 is assigned into this CPU. So this is called as shortest job with preemptive, shortest job first with preemptive version. So this is also called as shortest job remaining ఫస్ట్. అంటే రిమైనింగ్ జాబ్తో కంపేర్ చేసినప్పుడు ఏదైతే షార్టెస్ట్ వన్ ఉంటుందో దట్ ఈస్ అసైన్ టు ద CPU ఫర్ ఎగ్జిక్యూషన్. సో దిస్ ఈజ్ వాట్ ద కాన్సెప్ట్ ఆఫ్ CPU బస్ shortest job remaining first. Now see the example for this. So this is what the shortest job preemptive. That means here arrival timings are given. These are the arrival timings at 0th arrival time. If the burst time is 7, that means comparatively these 4 burst time is here minimum. P3 process has a minimum burst time, but this P3 process arrives into the CPU at 4 milliseconds. So in the remaining 3 milliseconds the CPU is in never ideal. So that in the 0th arrival time P1 process entered. Okay. So after completion of 2 milliseconds, now P2 process entered. After completion of 2 milliseconds, P3 process enters. After completion of this one, that means 5th arrival time, next P4. So that here you can observe first P1 process is executed. So here a remaining time is what? 5. That means 2 milliseconds are completed. Then 5 milliseconds are left over. Okay. Then here P2. At second arrival time, here 5, here 4. At second arrival time, which process is entered into the CPU? That is P2 process enter into the CPU. After completion of 2 milliseconds, means at 4th millisecond, so P3 process enter into the CPU. So its bus time is 0. That means only 1 millisecond is its bus time. Okay. Now it is come from the CPU as well as it is deleted from the ready queue also. Okay. And after that, at 5th milliseconds, P4 process is entered. That means at 5th millisecond, P4 process enter into the ready queue, but not assign into the CPU, because here compare all the burst timings for P1, P2 and P4. So P1 remaining time is 5 milliseconds, P2 remaining time is what? 2 milliseconds, P4 remaining time is 4 milliseconds. So comparatively these three, which one has the minimum burst time? P2 has the minimum burst time. Now P2 enter into here, this is completed 2 milliseconds. So after that next P4 is executed, that means here 5 milliseconds, here 4 milliseconds. So that first P4 is processed and after that P1 is processed. So this is the concept for how to execute that. That means here you can observe average waiting time. That means average waiting time, how we are find out like this. That means average waiting time for this P1 process, here 0, there is no waiting time. Here at 11th, that means 11th, the process is entering into again CPU. That means waiting time is here 2 milliseconds, the process is in the CPU, 11 minus 2, 9. P2, so P2 waiting time is what? That means P2 process 2 at 2 milliseconds only P2 process enter into the CPU, but again the process is here, that 5 milliseconds. That means here in this case 2 milliseconds P2 process is busy in the CPU, there is no waiting. So after that at 4th milliseconds another process enter, now P2 to waiting position. So that this P2 process waiting time is what? 5 minus 4, 1. And coming to the P3 process enter into the 4, and that means another, that means nowhere again the P3 is entered. That means the minimum bus time is only 1 millisecond, this is completed. Now 4 minus 4, 0. Now coming to the P4, the P4 process enter into the CPU at 7th millisecond, arrival time is what here? 5. That means 7 minus 5 is nothing but 2. This is the average waiting time. So that how we are find out the next length of, that means determine the length of next CPU burst. That means it is depends on the next length of CPU burst time. That means it can only estimate the length. So next CPU burst time enta, each and every process next CPU burst time enta ane danipena this preemptive version is executed. So this can be done by using the length of the previous CPU burst using this formula. Okay, before that can explain, that means before this, here see one more example for this. That means in this previous case, here some ambiguity is there, how we can find out the waiting time. So for that we have some formulas. So the formulas you can find out that is so this is the example for shortest remaining time first. So this is the shortest remaining time first. That means for every one unit time, identify the which is the shortest job. Which one is shortest one? Suppose you can observe here, the criteria is here shortest job first, that is the remaining time. This is a mode is preemptive mode. Okay. Now observe here, first 6 processes are there. Arrival times are this 1, 2, 3, 4, 4, 5. These are the arrival timings. 7, 5, 3, 1, 6, 4 are the bus timings. Now see here how it is working. Shortest remaining time first. That means at arrival time 1, process P1 enter into the CPU. Okay. So after completion of 1 second, 1 millisecond, at arrival time 2, process P3 enter into the CPU. That means process enter into the CPU means here the remaining bus time is what? 6. That means 1 millisecond is completed. Next, after that means at arrival time 2, P2 is enter into the CPU and executed 1 millisecond. At arrival time 3, now process P3 enter into the CPU. So here what is the remaining time? Only 1 unit is executed, that is 4. Now coming to the next here, at 4 milliseconds, 2 processes, P4 process and P5 process, both of these 2 processes are executed. So in this case, which one is first enter into the CPU? In this case, first which one is enter into the CPU means which process have the minimum burst time. That means minimum burst time. Here P4 process has a minimum burst time is 1. P5 process has a burst time 6. That means out of these 2, which one is minimum? P4 is the minimum. So that P4 enter into the CPU. P4 enter into the CPU. So after completion of this 1 second, only 1. Now 1 completed. That means 5 units. Next here at 5 P6 process enter into the CPU. At 5 P6 process enter into the CPU. But here you can observe first P1 bus time is leftover time is 6, P2 4, P3 2. Next P4 is completed, P5 is 6 and P6 4. That means coming to the bus time, that means at time 5, all the processes P1, P2, P3, P4, P5 and P6, all the processes are in the ready queue. That means at arrival time 5, all the processes are stored in the ready queue. From this ready queue, which process is selected by the short-term scheduler, that is decided based on the shortest job. So here there is a shortest remaining time first. So remaining time means once it is executed and remaining bus timings. So all these remaining bus timings which is the minimum, which has a minimum, that is here 6, here 4, here 2, here 6, here 4. Out of this 2, bus time 2. That means which process has a bus time 2? P3 process. Now the P3 process enter into the CPU. Now this is completed. So after the completion of this one, now coming to this 6, 4. So 4 and 4 both are same. So if the bus times are same, then which process enter into the CPU first? Which process has the lowest process ID? So now P2 process enter into the CPU. Now the P2 process enter into the CPU. This 4 seconds are completed. 7 plus 4, 11. So the next 6, 4. So from this 6, 4, which one is first executed? That is 4 is first executed. So that P6 process enter into the CPU. That is the bus time is 4. 11 plus 4, 15. Okay, it is completed. Then next, after this 15, now another one. That is what? P1 and P5. These 2 processes both have 6 and 6. So the remaining time for these 2 processes have 6 and 6. So if the bus timings are same, which one is first enter? Lowest process ID is first enter into the CPU for execution. That means P1 is first here. 15 plus 6, 21. Next P5 is entered. That is 21 plus 6, 27. So this is what the concept. Now find out here the average waiting times and average turnaround times. So for that, it gives the ambiguity. That means, so how you are find the waiting time for P1? P1 waiting time. Suppose P1 enter into here 1 millisecond. Okay, so that next P1 enter into again 15th millisecond. 15th millisecond. So that means P1 process is in the CPU. How much time? 1 millisecond. The CPU is in the busy position. That means it enter at 1 millisecond, and after 1 millisecond it comes out from the CPU. So that at second millisecond it comes out from the CPU. So that what is the waiting time? That is 15. This is the waiting time minus this 2. That is 13. Okay, coming to the P2. So here P2 at arrival time 2, it enter into the CPU, and again this again enter into the CPU one more time at 7th millisecond. So this is what here in this case the process is in the CPU only. That means at 3 milliseconds to 7 milliseconds the process is in the waiting portion. That means 7 minus 3, 4. So coming to P3 process, here 5. So P3 process enter into the CPU at what time? 3. Waiting time is what? P3 waiting time is 3. So the P3 enter into the CPU at 3, and waiting time is what? Arrival time is also 3. So that here 0. This is 0. Okay. P3. Okay. ఇక్కడ ఏం కావాలి మనకి? సో దట్ మీన్స్ హియర్ బట్ ఇక్కడ ఎందుకు వెయిటింగ్ టైం 1 వచ్చింది అంటే ప్రాసెస్ మనకి ఎక్కడ స్టార్ట్ అవుతుంది? 0 మిల్లీసెకండ్ లో స్టార్ట్ అవ్వలేదు, 1 మిల్లీసెకండ్ లో స్టార్ట్ అవుతుంది. కాబట్టి హియర్ ద వెయిటింగ్ టైం ఇస్ ఫ్రమ్ హియర్ టు హియర్, ఫ్రమ్ హియర్ టు హియర్ 2 milliseconds only it is in waiting portion. That means 3 ఇక్కడ 3 and arrival time 1, ఇక్కడ నుండి ఇక్కడికి and ఇక్కడ నుండి ఇక్కడికి ఓన్లీ 2 milliseconds మాత్రమే వెయిటింగ్ టైం లో వెయిటింగ్. దట్ మీన్స్ అంటే ఇక్కడ ఏమవుతుంది? 3 minus 2 means what? 1. 3 minus 2 only 1 millisecond the process is in waiting portion. అంటే ఇది find out చేయాలి అంటే here we have some ambiguity. So that instead of analyzing this type of that means instead of finding the waiting times, applying these analysis, just we are using some formulas. So how we can apply those formulas? So before for that, first take the complete timings, completion time when the process is completed. Means coming to here, P1 process completes at 21 milliseconds, P2 process completes at 11 milliseconds, P3 process completes at 7 milliseconds, P4 process completes at 5 milliseconds, and P4 process complete P4 5 and P5 complete at 27 milliseconds, and P6 completes at 15 milliseconds. So these all are the completion timings. Okay. After this, find out the turnaround timings. When the process is turned around, means how much time the CPU is in the every time again. Say this is turnaround time in nothing but the process is in the ready queue as well as in the CPU. So that is totally is called as turnaround timing. Okay. Now that is what here P1 process. So this is the P1 process. Turnaround timing is this one. That means completion time minus arrival time when that process is completed, and this is okay 1. That means suppose you can observe here the waiting time. That means when the process is 1. That means ఇక్కడ నుండి మనకి ఇంతసేపు అంటే రెడీ క్యూలో ఉంది, లేదు అంటే రెడీ క్యూలో అయినా ఉండాలి, అదర్వైజ్ సిపియూలో అయినా ఎగ్జిక్యూట్ అవ్వాలి. అంటే వెయిటింగ్ పొజిషన్లో ఉన్నా ఉండాలి, లేదంటే ఎగ్జిక్యూషన్లో అయినా ఉండాలి. సో ఇక్కడ వెయిటింగ్ ఎగ్జిక్యూషన్ ఎంతసేపు? 1 milliseconds. వెయిటింగ్ ఎంతసేపు? దట్ మీన్స్ 15 along with execution. మళ్ళీ again the execution is what? 6. That means 1 plus waiting time is what? Here the 15 and 1. Waiting time is what? How much time it is in waiting position? 30 milliseconds. 1 plus 13, 14 plus ఇక్కడ ఎంతసేపు ఎగ్జిక్యూట్ అవుతుంది? 6 milliseconds. That means the process is in the waiting position. That means in the ready queue or waiting queue. అంటే రెడీ క్యూలో ఏంటి? రెడీ టు ఎగ్జిక్యూట్ నథింగ్ బట్ అల్టిమేట్గా మనకి రెడీ క్యూలో ఉంటుంది. సో వెయిటింగ్ క్యూలో ఎంతసేపు ఉంది, రెడీ క్యూలో ఎప్పుడు ఎంటర్ అవుతుంది, దెన్ నెక్స్ట్ సిపియూలో ఎంతసేపు ఎగ్జిక్యూట్ అవుతుంది. సో దిస్ ఈజ్ నథింగ్ బట్ టర్న్ అరౌండ్ టైం. ఓకే, దట్ ఈస్ సింప్లీ ఎలా ఫైండ్ అవుట్ చేస్తాం, కంప్లీషన్ టైం మైనస్ అరైవల్ టైం. ఓకే, కావాలంటే ఇక్కడ చెక్ చేయండి. హియర్ 1 second the process is in CPU. Here the 6 seconds the process is in CPU. That means total 7 seconds. What is the burst time? 7 seconds. So after that waiting time, that means 1 second ఇక్కడ ఉంది, సెకండ్ మినిట్లో బయటకు వచ్చేసింది. దెన్ నెక్స్ట్ ఇక్కడ చూడండి 15 మినిట్లో ఎంటర్ అవుతుంది. అంటే ఇది 15 minus 2 13. 13 plus 7 means 20. We got 20. So this is takes a time taking process, so that we can apply some formulas, that is completion time minus arrival time. Here completion time for P2 is 11 minus 2 9. Here 7 minus 3 4. Here 5 minus 4 1. Here 27 minus 4 23. Here 15 minus 5 10. Okay, this is the turnaround time. Total turnaround time is 67 milliseconds. All the processes are waiting as well as in execution. So turnaround time is 67. Okay, and what is the waiting time? Waiting time, how we got the waiting time is, that means turnaround time minus burst time. Turnaround time ఇంతసేపు మనకి రెడీ క్యూలో ఉంది, సిపియూ ఎగ్జిక్యూషన్లో ఉంది. దాని నుండి బస్ టైం మైనస్ చేసామనుకోండి. ఓకే, అంటే ఎంతసేపు ఎగ్జిక్యూట్ అవుతుంది, ఎంతసేపు వెయిటింగ్లో ఉంది, మొత్తం కలిపి టర్నరౌండ్ టైం. సో దీంట్లో నుండి బస్ టైం మైనస్ చేసి మనకి ఏమొస్తుంది, వెయిటింగ్ టైం వస్తుంది. దట్ ఈస్ 20 minus 7 13, 9 minus 5 4, 4 minus 3 1, here 1 minus 1 0, 23 minus 6 17, 10 minus 4 16. So these all are the waiting timings. That means total waiting time is 41. This is the average waiting turnaround time and average waiting time. Suppose this is another question. Now this is another question. Observe here. P1. These are the 6 processes. Arrival timings are these. Okay, and burst timings are these. Now coming to here, it's second millisecond. That means you can observe here 2 3 5 4 3 2. That means 0 millisecond లో ప్రాసెస్ ఎంటర్ అవ్వట్లేదు, అండ్ 1 millisecond లో కూడా ప్రాసెస్ సిపియూలోకి ఎంటర్ అవ్వట్లేదు. ఎట్ సెకండ్ మిల్లీసెకండ్ ద ప్రాసెస్ ఎంటర్ ఇన్ ద సిపియూ. దట్ మీన్స్ P3 ఎంటర్ ఇన్ second millisecond the process is P4. Observe here, at second millisecond P4 process enter into the CPU. So after the 3, that means at after completion of 1 millisecond, P1 and P6 both are entered into the CPU. P1 process burst time is 1, P6 process burst time is 3. Okay, first which one is the processor? That means P1 is processor. After completion of this 1 millisecond, that means arrival time is 4. At 4 milliseconds, P3 process is there and P6 process is already there, and next P4 process is already there. So 3 processes arrival timings you can observe here. That means at arrival time 4, P1 process completed and P4 process is in the queue, and P6 process and P3 process. Out of these 3 processes, you can find out which process has a minimum burst time. That is P3 process burst time is 2, P6 process burst time is 3. Next, what here? That is at arrival time 4 3 P1 completed, P4 is 4. So that out of these 3, P3 is minimum. So that P3 enter into here. After completion of 1 millisecond, now P2 process enter into the CPU, but CPU burst time is 6. P3 burst time is leftover burst time is 1. P4 burst time is 4. And P6 burst time is 3. So from these 4 processes, P3 is the lowest one. Means this is completed. Next 4th millisecond, that is completed. Now 6 millisecond, P5 process is also entered into the ready queue. Now all are in ready queue. Out of these, P1 and P3 are completed. Next P2, P4, P5, P6. So from P2, P4, P5, P6, which one has a minimum? That is 3. మీరు అబ్జర్వ్ చేస్తే 3, 7, 6, 5. So out of these 4, 3 is the minimum. So that this is completed first. P6 is completed first. After completion of P6, from these 3, that is P5, P4, P2, which one is the minimum? P4 is minimum, that is 9 plus 6, 13. Sorry, 9 plus 4, 13. Next, which one is minimum? P2, that is 13 plus 6, 19. Next, P5, that is 7, that is 26. This is what the concept. Do you understand? Next, here first take the completion timings, that is P1 4, P2 19, next P3 5, P3 6, next P4 13, next P5 26, next P6 9. Completion timings. Then next find out the turnaround timings, that is completion time minus arrival time. 4 minus 3 1, 19 minus 5 14, 6 minus 4 2, 13 minus 2 11, 26 minus 6 20, 9 minus 3 6. Waiting timings, that is turnaround time minus first time, that is 4 minus 1 minus 1 0. Here 14 minus 6 8, 2 minus 2 0, 11 minus 5 6, 20 minus 7 13, 6 minus 3 3. Now find out like this. So this is what the shortest remaining time first. So like that, this is another example. You can post all these questions in the class. So already మీకు notes కూడా నేను OS notes change చేశాను. Notes చూడండి. So this is another example for the shortest job itself. Next we can discuss about the other algorithm. So that algorithm is priority scheduling algorithm. Okay. So this priority scheduling is this algorithm associated some priority with each process. Each and every process has some priority. Based on the priorities only, the processes are processed inside the CPU. That means a priority number, nothing but this is an integer, is associated with each process. Here again this priority scheduling also have two versions. One is a preemptive version and another one is a non-preemptive version. So the CPU is allocated to the process with the highest priority. That means smallest integer, nothing but highest priority. Suppose whenever any process a priority number is associated with each process. That means each and every process assigned some priority. So which process is first allocated to the CPU? That means highest priority. Here highest priority nothing but smallest integer. So which process has a smallest integer? Which process has smallest integer or smallest integer number? That is goes to the highest priority. Now that first assigned to the CPU are allocated to the CPU is allocated to that particular process for execution. Now here in the shortest job first is a priority scheduling where the priority is a predicted next CPU bus time. అంటే shortest job first అనేది ఒకవేళ CPU bus time పైన డిపెండ్ అయింది అనుకోండి, then shortest job first is a priority scheduling where the priority is predicted next CPU bus time. Next CPU bus time కనుక దేనికైతే తక్కువ ఉంటుందో దాన్ని కనుక మనం హైయెస్ట్ ప్రయారిటీగా ట్రీట్ చేస్తే నో దట్ బికమ్స్ ఏ shortest job first algorithm, now becomes a priority scheduling algorithm. Here some problems are there, that is what is that starvation? Means starvation in the sense if the low priority process have highest that means low priority processes may never execute. Low priority process may never execute. అంటే low priority process never enter into the CPU. Okay, so in that case this is called as a starvation. Means suppose here first see the example, next we can discuss about that one. First see the example for this problem. Observe here, this is a non-preemptive version of priority scheduling. So in this case, criteria is priority scheduling, and mode is non-preemptive. So here observe, these are the priorities. Okay, these are the priorities. Smallest integer, and based on the that means highest priority. That means here in this case, highest priority was the highest number. But in the here we observe that priority number, smallest integer was the highest priority. That is, assumption is depends upon us. Okay, assumption is depends upon the us. Here this is the highest priority. Suppose highest integer was the highest priority. Otherwise this was the highest priority. Suppose this is the highest priority. Highest number goes to the highest priority. For example, here, and next one is this one, and next is this P3, P2 process. Next P1, next P4, next P5. That means first priority goes to P3 process. Next priority goes to P6. Next priority goes to P2. Next P1. Next P4 and P5. So these are the arrival timings, and this is the first step. So in the question, so they can give up to priority numbers, process IDs, and arrival timings, bus times. So this is a non-preemptive version. Means once the process, once the CPU allocated with some process, that process never preempted until completes its CPU burst time. CPU burst time completed that process not preempted from the CPU. Okay, now see here, first which process enter into the CPU? That is highest priority. Now here assume the highest integer goes to the highest priority. So that P3 process enter into the CPU. First, before that the arrival time here 2. But observe here the arrival timing at 0, P1 process entered. P1 process entered. Okay. Now this P1 process entered at 0th millisecond. This is a non-preemptive version. Once this process assigned to the that means once this process entered in the CPU, total burst time is completed first. Okay, 4. Because non-preemptive version. Once assigned then complete manaki preempt kaadu. Okay, then next after that, at completion of these 4 milliseconds, P1 process, P2 process, P3 process, P4 process, P5 process. All these processes are in the ready queue. Observe here. P2, P3, P4, P5. All these 4 processes are in the ready queue. From these 4 processes, which process is scheduled or selected by the short-term scheduler? So here the scheduling criteria is priority. So that which process goes to the highest priority? P3 process goes to the highest priority. So that first P3 process is assigned into here. Okay, P3 process is assigned. Now what is the burst time for this P3 process? That is only 1. That means 4 plus 1, 5. So after completion of this P3, that means at 5 milliseconds, the queue contains P2 process, P4 process, P5 process, and newly P6 process is also entered into the ready queue. So once it is entered into the ready queue, now from out of these 4 processes, which process has the highest priority? That means next highest priority goes to P6. Now the P6 is entered into the CPU. That is 5 milliseconds. After completion of 6 milliseconds, that means 5 plus 6, 11. Next, that means P6 is completed. Next in the ready queue, P2, P4, P5. Which process goes to the next into the CPU? Which one has a highest priority? That means from P2, P4, P5, highest priority is, that is, highest priority process is next P2. That means P2 priority is 5. Okay. Then next P2 enter into the CPU. So P2 enter into the CPU. Okay. Then 11 plus 5. Burst time is 5. That is 16. So then next P2 is completed. P2 is also completed now. Then the ready queue only 2 processes are there. P4 and P5. So coming to the P4 and P5. So which one has the highest one? P4 is the highest one. So that P4 enter into the CPU. 6 plus 16 plus burst time is 2. 18. Now, after that only P5 process is there, that is selected and assigned to the dispatcher to the CPU by dispatcher. Now the bus time is what? 6. 18 plus 3. What is the bus time here? 3. That is 26. Now take the completion timings for P1 4, for P2 16, for P3 5, for P4 18, for P5 21, P6 11. Coming to the turnaround timings, that is completion time minus arrival time. 4 minus 0, 4, 16 minus 1, 15, 5 minus 2, 3, 18 minus 3, 15, 21 minus 4, 17, 11 minus 5, 6. Okay, this is the 60 is the total turnaround time. And coming to the waiting timings, that is turnaround time minus bus time. 4 minus 4, 0, 15 minus 5, 10. Now 3 minus 1, 2. Here 13, here 14. Next 6 minus 6, 0. Okay, so total waiting time is 39. So these are the average total turnaround time. This is the average waiting time. So this is what the priority scheduling. Okay, so in the next session we will discuss that priority based scheduling with preemptive version.